And I am going to start with a different question than these, and I don't have the place it came from. But I didn't see one like it in this review. If I did, I skipped it. This is when you have a log. This is the question. All right. And you're not able to use your property to write this 22 in terms of 18 to something, right? And that would be your strategy, is to get these bases the same. And so the way to work this is set it equal to a variable. We'll call it y. And then change your form. So do your spiral around the equals. So we have 18 to the y equals 22. And now you can take your log of both sides to get your variable down. So we'll take natural log of both sides. And that will make the exponent come down. So we have y times ln of 18 equals ln of 22. And then you're going to solve for y. So you are going to divide on both sides by the natural log of 18. That is the exact answer. And then you would put it in your calculator to get an approximation to whatever they said. So natural log of 22, just make sure you close your parentheses, divided by natural log of 18, close the parentheses, enter, and we'll say it went to 4 digits. So now we're approximate 1.0694, and a 2 would drop off. So 1.0694. So this was just one that I didn't see one like it in your work. All right, now we'll go through your problems. All right, so question 8 was the first one that was requested. And this is going to be just changing a form to use one of your properties. Actually, you're just going to change this. So you're trying to get it into your form log base b of b to some power. Right, and you have a couple things going on in this one. You see the 6, so you're going to be able to get there. For it to be in the denominator, remember that's a negative exponent, and it has a root that is a fractional exponent. So we need to rewrite this piece that we're taking the log of. So the log base 6 of 6 to the negative 1/3. The negative 1, the negative puts it to the denominator. The 1/3 gives you the radical down there. Right? And then the answer will be negative 1/3 once you get these bases the same. You guys stop me if you have a question as I go.
I have a quick one real quick.
Okay.
So could it also be done as like the outside of the radical is like the top and the inside of the radical is the bottom? Like of the, like so then it would end up being 1/3? Or no?
Run that by me one more time.
Sorry, so the outside of the radical on the bottom, like, would go on the top, and then the inside would go on the bottom, like of your fraction, like if you pull it out, and it'd be like a negative 3/6. Oh, wait, nope, never mind, that doesn't work. I'm sorry.
That's okay. That's okay. I just wasn't following.
I was.
You were thinking of another power in here?
Yeah,
okay.
that was where my brain went. I'm sorry.
That's okay. That's okay. It's a good question because it pulls in two things that you have to look at. For something in the denominator, make it a negative exponent. And for a root, make it a fractional exponent.
Thank you.
You are welcome. All right, the next one I have is 12. All right, and this one asks us to expand. So we have the log of 1,000 over t. So you have to remember the property that the log of a quotient is the difference of the logs. So this is going to be equal to log of 1,000 minus log of t. Right? And then you have to clean up any that will. And this log of 1,000 will clean up because your base on this common log is 10. So I'm going to slide this a little bit. I like to keep the equals lined up, but I didn't space it good. So if we write this as log base 10, just so we have the 10 in our mind, this is 10 to the third. And then you can simplify because your base is the same. This is a 3. So 3 minus, the other piece you can't do anything with. So it is going to stay, and we have 3 minus the log of t. So that is expanding. And next I have 14. This one is a condensing problem. So you're going to put them back together. And this one is also a difference, so it will go back to a quotient. Right, and first I would put the exponents back on. These, once you have the coefficient, that is an exponent. So put those back on. So then I have the log base 4 of z to the 10th. And we have the log base 4 of y to the 18th. And that's a 4 and that's a y. Sorry about that. All right, and then you can put them together and make one log base 4 of z to the 10th over y to the 18th. All right, and problem 15 is a change of base question. So the log base 27 of 8, and I taught you guys to do it. You have to watch these because whichever one it says to use, it will say natural log or common log. This one says use common log, so I need to use the word log. So take the logarithm of the number that is higher up in position. So 8 is higher. So take it on top over the log of the one that's down low, 27. And now it's log base 10. These can go in your calculator. This will actually be your first answer that is exact. And I should have put my parentheses. And then you can go in your calculator and it is log base 8 close divided by log base 27. Sorry, of 27, not base. It's base 10. And so now this is approximate 0.63092. And if they said 4 places, we'll drop the 2 off. So this is an easy thing to do, and that is probably a 3-point question on there. All right. Just came to mind something I want to do before the end. I did not see it in one of these review questions, but domain. All right. So remind me to talk about that at the end, and we'll talk about it when we check. All right. 16 is going to be a solved problem. It has equals in it, and I better get a new page. I might need a little bit more room. So this is an exponential equation. You don't see any logs there. And we can try to solve them by making the bases the same. If you can get the bases the same, then you can set the exponents equal and solve. And so our candidate would be 10. To write them in terms of 10, since this is in the denominator, and it is a power of 10, it's 10 squared. So this 1 over 100 would be 10 to the negative 2. Then you're good. Once your bases are the same, you set the exponents equal and you solve that equation. So negative 2 equals 5x minus 7, a nice linear equation. We will add the 7. So 5 equals 5x, and divide by 5. X equals 1.
I have a quick question.
Okay.
Your 12 was different than my 12. My 12 was log, and then it was in parentheses 100v. It wasn't like over. It wasn't like a fraction like that.
Okay.
Is there any way to see one like that?
Sure. If you can tell me what it is, because these are randomly generated, and if I don't pull it off of your page, it's not going to be the exact same one. So that one was finished. Just read me your problem.
Okay, it's log, and then in parentheses 100v. It's not like to the
Z or V?
V is in Victor.
Okay. That's all we have?
That's it, yeah.
And there's nothing else there?
It's like an equals. Just an equals. That's the only thing that it is.
Okay.
Yeah.
And so let's go back and see what the directions were on 12. Because the directions would be the same. All right. So the directions say expand. This is good because this is the other kind that we didn't have. And this is a product. So to expand it, it is going to be the sum of the logs. If it is a quotient, so a fraction, then it would be minus. So this one is going to be log of 100 plus log of v. Whoops, it should say log. And this piece of it you can simplify because these are log base 10 and 100 is 10 squared. So that simplifies to 2. So it's 2 plus log of v. And that would be your answer. So this one was a product instead of the one that I had was a quotient. Does that help?
Yes, thank you so much.
Okay, you're welcome. And I'm happy to answer whatever you guys want. This is your session. Okay. All right, let's see. So we did 14. And we did 15. That was a change of base. And we did 16. So that was the first solving one. All right, so this one is also an exponential equation. the goal is going to be to write them with the same base. And so if you rewrite this first one as e to the negative 1, then you can set the exponents equal. So negative 1 equals 4t plus 1. Subtract your 1. Negative 2 equals 4t. And divide by 4. T will be negative 1/2. All right, for this one, it is an exponential equation. You're going to try to write them with the same base. You're not going to be able to use 81 because if you just do 81 squared, that's way bigger than 243. So you have to try to do something else. And 81 is a power of 3. It is 3 to the 4th. So we will get our calculator and we will play. And we will try let's try 3 to the 5th and see if that is 243. And it is. So that was a good guess. 3 was the only thing you could have tried 9, but 9 squared is 81 times another 9 is going to be way bigger. All right, so just things that divide into 81 is what you would have tried there. All right, so I said that 3 works for the base. So this is 3 to the 4th to the x, and this is 3 to the 5th. And then you're good once you get that. And these two will multiply. So you're going to have 4x equals 5 and divide by 4. So x equals 5/4. Good. This next one is already set up for you. It is an exponential equation, but it has the same basis. And so you will set the exponents equal. You just have binomials there. It's not a big deal. It is a linear equation. So you're going to get rid of an n. So I have 6n, and I'm going to add a 6. And then we will divide by 6. We will need to reduce here. Common factor of 3. 3 will go into 15. 5 times 3 into 6 will go 2 times. And you can use your calculator to do that if you have any issues. All right, 20. All right, it is an exponential equation. Your goal will be to write these in terms of the same base. And 9, you could do 3 squared. It's in the denominator, so it will be to the negative 2. Now you're allowed to set the exponents equal. So negative 2 equals 5n minus 6. And so we will add a 6. And divide by 5. Next one you have to think about a little bit. So 343, oh, I don't know anything that gives that. But you'll look at the other one and it's 49. For 49, really, your factors are 7. All right, 7 times 7. So on our calculator, we should see if we do 7 to some power, can we get 343? And so let's try 7 to the third. 343. So this will be 7 to the third, y minus 3, and then these will multiply, and you have to be a little careful there. This will be 7 squared, and this will be y minus 5. These are going to multiply. All right, so we are allowed to bring those down, but here we're going to have 3 times y minus 3, and over here we're going to have 2 times y minus 5. So here we'll distribute 3y minus 9 over here, 2y minus 10, and then get rid of a y, so 3y minus 2y is y, and add your 9, negative 1. This next one, it is the first exponential equation where we cannot rewrite 57 as 3 to a power. So we're not going to be able to get them as the same base. So we need another technique to solve. And what you can do is take a logarithm of both sides because of that property. That if you have a logarithm of something to a power, the power will come down. You want this t to come down. So the logarithm of m to the n makes the n come down like that. So that's the property we're going to use. So we'll take a log of both sides. I'm going to use a natural log. Doesn't really matter which one you use. Makes the t come down. You do have to watch their words if they specify how this exact one is supposed to look. They did not use the word common log. They just said logarithms. So it should accept either one. That change of base is the one that will switch it up on you. Right? And then to solve for t, you're going to just divide this natural log of 3. It is just some number. We don't know what it is, but it's some number. So this should be your exact answer. And it could have been with logs, with common logs. I think they would take either. And then go to your calculator. So natural log of 57, close the parentheses, divided by natural log of 3, close the parentheses, enter. 3.68014, and the 4 would drop off. It's not enough to push you up. '23 is a good reminder that you have to isolate the piece with the exponent before you take a log of both sides. So the first thing we need to do is get the 4 to the other side. So we'll add a 4, and that will give us 699. So we have e to the negative 8c minus 6 equals 699. We're going to take a natural log of both sides. Here you have to take natural log because you have e. And that will make this come down. So we have negative 8z minus 6. It's times the ln of e, which is 1, so we don't need that. Right, then we're going to isolate the z. So first we're going to add the 6. We're not going to calculate that yet. Right, and I'm going to have to back up. I'm sorry I didn't leave enough room on this one. All right, so I have natural log of 699 plus 6. Now that's not taking the log of it. The log is of this one. I should be a little clearer there. Right, and then I'm going to divide by negative 8. So this is actually my exact answer if they ask for it right here, which they did. Right, and then I want to put it in my calculator. All right, and you're going to do math on your numerator. So your choice is to use a big parentheses at the beginning and do all your numerator in it and then divide, because you only have one number here. Or you can do all your numerator, hit enter, and then hit divide. Those are your choices to do it correctly. We'll throw the parentheses on. All right, so natural log of 699, close that parentheses, plus 6, close the numerator, divided by negative 8. And so we get, and we're going to round this, so it'll be approximate, negative 1.56870. So we'll go just to the 7. All right, 24 is our first one that has a logarithm on it. It is an equation. And with the log equations, basically there's two types. If you have log only on one side, you will condense if there's more than one, and then you will change the form. If you have log on both sides of the equal sign, you will be able to drop the logs and set the arguments equal. All right, so this one we're going to change our form, which we've been doing this from the beginning, but now we'll have to use it to solve. All right, so we're going to have 6 squared equals u minus 11. And you don't have the log anymore. So you have 36 equals u minus 11. Add your 11. And so we have 47 equals u. Now, every logarithm equation, you have to check the answer. And what you're checking is that the domain is okay. You don't have to check through the whole thing. But you need to plug this in to the part you're taking the log of and make sure that it would still be greater than 0. So if we put a 47 in, 47 minus 11, that's still going to be positive. I don't care exactly what it is, but it's going to be positive. So it's okay. All right, so make sure that you check on these. So 47 is going to work. Oh, this, I didn't check it there. This was what they wanted first. Changing the form. Right, 25 is also going to have us change the form. All right, and so you're going to do your spiral. Start at the 3, with your base, and go around the equals. All right, so 3 to the negative 2 equals 3u minus 11. This is going to be 1/9, so you would shift it to the denominator, and then it gives you a 9. You're going to multiply on both sides by 9 to get rid of your fractions. So you have 1 equals 27u minus 99. Right. Add your 99 to both sides because it's a linear equation. And we get 100 equals 27u. Divide by 27. And I don't see anything there that will reduce. So that should be our answer. Now we have to go back and check. All right, so I'm going to get a decimal for that. So I have 100 divided by 27 equals, and that is going to be times 3. All right, and this one was very close, right? Because we want this entire piece here to be greater than 0. Well, this gives us 11.11. We're taking away 11, so 0.11, but that is greater than 0. So it works. But you do need to check that each time. Each logarithm equation. It's the kind you have to check. So if you have just a question that's about the domain of the log, it's this piece right here that you look at and you set it greater than 0 and solve that inequality. All right, and I should look at the answer, I guess. All right, this one has 2 logs. They are on the same side of the equation, so you can condense. This is why you learn to condense. So these two are going to go together. It's a difference of log, so it's going to be the log of a quotient. So 1 log base 5 negative 4x plus 7 over 10x plus 16 equals 2. Now you can change your form. So 5 squared equals this piece you were taking the log of. So 5 squared equals negative 4x plus 7 over 10x plus 16. So this is a 25, and you're going to multiply on both sides by 10x plus 16. And this side it will cancel. Clearing a fraction. All right, and so this gives me 250x plus, this seems really big, but we'll see. I didn't see anything else wrong. So 16 times 25, 400 equals negative 4x plus 7. All right, so we will get rid of one of the x's. So I'm going to add 4x to both sides, and that will give me 254x. All right, and I'm going to, if you were in my 1033 class, I wouldn't let you do this. I'd make you write these steps. But I'm going to do them both on the same line. So I have 7 minus 400 would be negative 393. And we'll divide by 254. All right. So that should be our answer if it doesn't reduce, if it checks. So we have to go back to the original, not where you condensed. You have to check all these original ones. All right, so we need to see this piece. We're We're probably going to be okay on this first one because you're going to have a negative times a negative will make a positive plus a positive. It's going to be okay. All right. But this one we have to watch. So we have, because I don't know what this value is. So I am going to punch it in. So negative 393 divided by 254. Enter. All right. And I'm going to multiply times 10. All right. So it is negative 15.47. But I have a positive 16, so it's okay. That's bigger than my negative number, and so it is okay. But you have to go through that. So it does check. All right, 27. We're going to need to condense first. It is a log equation. The logs are only on one side, so we want to put them together and make one log. Whoops. I don't know where I got that 9. Okay. This one is a sum of logs, and remember that is the log of a product. So that is the log base 2 of x plus 9 times x plus 6. And then we'll change form. So we're going to do 2 squared equals this piece. 2 squared equals x plus 9 times x plus 6. 2 squared is 4, and this will do a FOIL. So we have x squared plus 6x on the outside plus 9x would give us 15x and plus 54. Now we want to get a 0 on this side because we have a quadratic equation. Subtract your 4, and you also have to subtract it here. Right? And then we'll try to factor the right-hand side. So 5 and 10. We're going to work there. And we can solve. So we have x equals negative 5 and x equals negative 10. So I'm real concerned with these, seeing negatives there. We have to go back and check in the original. Right, when you plug in negative 5 plus 9 is okay. 9 minus 5 is 4. Right, and negative 5 plus 6 is okay because that's a positive 1. So negative 5 is okay. Negative 10 is not okay. Negative 10 plus 9 gives you negative 1. Log of negative 1 is not okay. So this one gets thrown out, and your answer is negative 5. You guys okay with that? It is necessary to check every logarithm equation. All right. 28. It is a log equation. The main thing is isolate first before you try to change forms. So we have 5 minus 3 natural log of v equals negative 4. So we want to isolate this. So we're going to subtract 5. So we have negative 3 ln of v equals negative 9. Divide by negative 3. So we get ln of v equals 3. Now you're going to change form. Remember, your base here is e, because you want to solve for v. E to the third is going to equal V. Right, and that is the exact answer. And to approximate it, you're going to, in your calculator, get your E. So second and divide has the E to the third. And this gives us 20.08553. And the 3 will drop off. Good. All right. 29 is your first one in this set that has the logarithm on both sides. And you have to condense so that you only have one log on each side. So you have the log of negative 14, W plus 8, plus log of 3 equals log of negative 11W plus 14. All right, so this side we need to condense so that we only have one log on each side. And this is a sum of logs, so it will be the log of a product. And I'm going to put the 3 first. It doesn't matter, but right, now that you have the log on each side, you can drop the logs and set the arguments equal. So we can set this equal to this, kind of like the exponentials. When you get the same base, you can set the exponents equal. So I have 3 times negative 14W plus 8 equals negative 11W plus 14. So we have some math here to do. So this will give me 42. Negative 42W plus 24. Right, and we need to get rid of a W term. So I'm going to get rid of this 11W. And that gives me negative 31W plus 24 equals 14. And now I need to isolate the W. So I'm going to get rid of the 24. I'll subtract it from both sides. This gives me a negative 10. And divide by a negative 31. So W equals. What you have to clean up here is your signs. The 2 negatives will give you positive. So 10 over 31. And then you have to remember to check in each one of the originals. You don't have to check in this log 3. There's no variable there. All right, and so we are checking 10 over 31. All right. Try to see it all in one shot. Because we're going to multiply that by a negative 14. So we're going to see what we're okay with there. So I'm just going to put it in my calculator. So 10 divided by 31. Enter. All right, and that is times negative 14. And that gives me negative 4.5. I'm adding a positive 8, so it's okay. 8 is bigger than this. So that piece of it's okay. I'm going to need to see this other piece. All right, so it is... So again, we'll have the 10 divided by 31, get our decimal. I put that in wrong. 10 divided by 31 times negative 11. That gives me negative 3.54. we're going to be okay with that one also because 14 is bigger than that, and the 14 is positive. So this one is going to be okay. We did check it, and this will be the answer. (10/31). All right, I'm going to skip 30, if that's okay, and go to 31. So we'll have time for a couple of word problems. So 30 we skipped, and if we have extra time, we can come back. All right, 31, I wanted to do one more with the log on both sides. And you will have to condense on the right-hand side this time. Right, and it is a subtraction, so it will be a quotient. So the log of t minus 10 over t minus 2 equals the log of t minus 7. And so you can drop the logs. That's all you have on both sides, and set the arguments equal. So t minus 7 equals t minus 10 over t minus 2. So we will multiply on both sides by t minus 2 to clear the fraction. On the right-hand side, it's going to cancel that piece. All right, so you have a FOIL on the left. So we have t squared minus 7t, and minus 2t is going to be minus 9t plus 14 equals t minus 10. And it is a quadratic equation, so you want a 0 on this other side. So we're going to subtract a t. That will give us a minus 10t. And we're going to add a 10, so plus 24, and that will give us 0. This one we're going to factor, like signs both minus, and how about 6 and 4? And then you set each one equal to 0. So t minus 6 equals 0, that is t equals 6, and this one will be t equals 4. Right, and we have to go back and check. So we're going to check for 6. 6 is not going to work. You have 6 minus 7 is negative 1. You don't have to check it anymore. So 6 is out. All right, and then we check the 4. And 4 minus 7 is a negative 3. 4 is not going to work either. And that is all the answers we had. Whoops. Okay, let's see. Maybe I just messed up right here. 31. Yes, I just got off my page. Okay. So 4 didn't work either. And so this one has no solution. All right, let's look at these word problems. And on here, they're mixed, which is probably a better way to give them to you. So you have to decide, is it a plug-in or is it a solve for an exponent? They're going to give you the formula every time. Right, and so this one is a compound interest formula. I'm going to just write the formula first. A is accumulated amount, P is the amount you put in, 1 plus R is your rate as a decimal, N is compounding intervals, and T is time in years. All right, so we're going to plug in. says use this formula to determine how long it will take an initial investment of $8,000 to grow to $23,200. We're solving for T. This one is going to be a solve, not just a plug in. So the accumulated amount would be the $23,200. The original is $8,000. 1 plus your rate, 12.59%. You have to switch it to a decimal. Drop the percent and go 2 places to the left. So 0.1259 divided by your compounding intervals. This one says it is compounded daily. And so we're going to use 365. And 365 is also here. And T is the piece we don't know. All right, so we've plugged everything in there. The first thing you have to do is get rid of this 8,000. It's multiplied by this piece with the exponent, so you're going to divide. So we're going to divide on both sides by 8,000. And I'm going to just go ahead and do that on the calculator real quick. We get 2.9. All right. I am also going to go ahead and work out the inside of this. This will give us a number. And I would do the fraction first in my calculator. So I'm going to hit clear. That's a bad habit, leaving stuff sitting in there. So 0.1259 divided by 365. Enter. All right, we're going to add 1. All right, so what we have here is 1.00034449. That's far enough. Times 365t. All right, now you're ready to take the logarithm of both sides. So I'm going to do natural log of both sides. And that will make your exponent come down. So we have 365t times the natural log of 1.00034449. And we're going to isolate the t. So these are all multiplied by the t. We're going to divide by them. We can do it in one shot. All right, let's say taking a shortcut there. All right, and these are all going out and giving your t on that side. All right, on this side, you have to be careful putting this in the calculator because you have an arithmetic operation down here. So you can put this one in first and put the entire denominator in parentheses, or you can put this one in first, hit enter, have the answer. I would use parentheses. Let's use the parentheses, okay? You just have to be careful to make sure that it does exactly what you want. All right, so natural log of 2.9, close that parentheses. That is your whole numerator divided by. We have math in there, so we're going to put the whole denominator in parentheses. 365 times natural log of 1.00034449. Close and close for the denominator. So we get 8.459 I don't remember how far out these said to go. We'll put 2 more just in case. This is T. And 2 decimal places. So I didn't need that much. The 9 will push the 5 up. So this will go to 6. So 8.46 years is your T. So that was an actual solve one because you wanted to know something that was in the exponent position. All right. 33 is just a plug-in. There was one of these that was tricky. This one. So you have to watch your words. All right, so it is compounded interest again. All right, and they are saying use the formula. All right, 14,000 is invested, and we want to know the accumulated amount. That's how you know that it is not one of the ones where you have to take a logarithm, because this is not an exponent. All right, your original amount is 14,000. The 1 is a constant. Your rate, 7.5%. Drop the percent and go 2 places to the left, 0.075. Now, the compounding here you have to read carefully because they're telling you 365 days in a year. But this tells you, and I'll use the mouse so you can see it, it's compounded annually. That means it only compounds 1 time in a year. So it would have to say compounded daily for you to use the 365. So I thought that was a little tricky myself. And 28 years. All right, so to work this out in my calculator, and it's important that you know how to push this in. All right, I'm going to start in my parentheses, and I'm going to do the fraction first. So 0.075 divided by 1, enter. Plus 1, enter. All right, that is my inside the parentheses. I'm going to write that much down. All right, 1 times 28 is 28. All right, order of operations, parentheses would go first, exponents go next. So I need to raise this, so it's still sitting in my calculator, to the 28th power. Right. Then I'm going to multiply by 14,000. And this gives me 106,000. And you might think, oh, no, that's a lot. That must be wrong. But it was 28 years. All right. And money is usually to the nearest cent. The 5 is going to push us up. So there we go. Good. I'm only going to do one part on that one. And I'm going to try to fit in one more question. 34 is also an interest, but it's a different formula. It is continuous compounding. All right, and we'll do just the first one. So we have $11,000 is invested, 13 years, so they're telling us T and they're telling us the rate. It's just a plug-in. We're looking for the accumulated amount. So 11,000 here. E, your rate is 3.5. Go 2 places to the left with your decimal. So 0.035. Your time is 13. Right, and now we're ready to just plug in our calculator. Again, the calculator is only as smart as the person pushing the buttons. You're going to do your exponent before you do this multiplication, but in your exponent position, you have an arithmetic to do. So you need parentheses around that part when you put it in. All right, so I'm going to put my E in. So second divide gets my E there. Raise it to a power. Because there's an arithmetic there, it's going in parentheses. 0.035 times 13. Close that parentheses. All right, now you can hit enter or you can do times 11,000. We'll hit enter. So that piece is done. Times 11,000. Enter. So A is 17,337 point, and to 2 places, this should be 9, 1. Good. All right. So we'll stop there. If you have any other questions I didn't get to, if you will let me know, I'll still be here in the office a little bit. I would be happy to do them as soon as my recording finishes on this piece. All right. You guys have a great day. I will look forward to seeing your test results.